Hey everyone, it's Elisa. In this lesson, we're going to be looking at 4 algebraic principles to help us solve an equation for x. Let's get started with our first algebraic principle. We are going to apply the subtraction principle to this equation, x plus 3 equals 8. Because there's an equal sign between the two expressions, this tells us that the x plus 3 is the same thing as the 8 on the right-hand side. To illustrate this on the mobile, I'm going to put a box around the left-hand side. So the left-hand side of the x plus these 3 individual kilos or pounds, that should be equivalent to, on the right-hand side, a value of 8. Some of these guys are 8 pounds, 8 kilos, whatever it may be. And we know at the moment that the two sides are balanced. They're equivalent to each other. And in the mobile, we see this because the left and the right-hand side right here, this is a horizontal plank, which means that they are equally weighted. If they were not equally weighted, then one side would be up like that, the other one would be down, or it would be reversed, where one side is heavier than the other. So when you're asked to solve for the value of x, you might be asked to do this in a couple of different ways. It's important to be familiar with the language. So I'm going to take a moment to say, you might hear solve for x. You might hear isolate. You might hear the word rearrange. Rearrange. So these are the most common ones. So if you're asked to do any of these things, that means whatever you got for your value of x, or whatever the unknown is, could be x, y, z, happy face, unhappy face. The goal is to isolate, to have it all by itself. So you have x equals something, and that something is what we're solving for. Okay, getting back to the equation, we want to solve for x, get rid of that plus 3. On the mobile, what we do know so far is that on the right-hand side, the right-hand side has a total mass of 8. All of this has a mass of 8 if we count each of these individual weights. So 1 plus 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 1. That is 8 pounds. On the left-hand side, since we have a balanced mobile, the sum on the left is also 8. Going to grab the green. So all of this has a sum of 8. How does the subtraction principle apply here? Well, in order for us to get this x by itself, to isolate it so that it's the only thing on the left-hand side of this equation, we need to move or get rid of the number 3. We are going to do this with the subtraction principle. So on the left, we have these 1, 2, 3, this plus 3 of weights. We need to subtract those 3 weights. Let's grab our red pen tool. So I'm going to subtract 1, 2, 3. If we subtract 3 from the left-hand side, so instead of having 8 now, we have 8 minus 3. This gives us a mass of 8 minus 3 is 5 pounds or 5 kilos, whatever unit you're measuring. If we do something like this to the left-hand side, is our mobile still balanced? Is the left-hand side and the right-hand side of our mobile equally weighted? Well, no, you just took 3 pounds away from the left. So that same action, if it's not done on the right-hand side, then you're going to have a mobile that isn't balanced anymore. The left-hand side will be lighter, which means that the right-hand side would be heavier. So if it is heavier, that means it's going to be dragging down. This side will go up, this side will go down. In order for us to maintain that balance so we don't have one side that's heavier than the other, we are going to be doing the same action on the left and the right-hand side. So if I were to say minus 1, minus 2, minus 3, on the right-hand side, I'm going to do the same thing. Minus 1, minus 2, minus 3. We take away 3 from the right-hand side. How many pounds are left? We got 1, 2, 3, 4, 5. Are the left and the right-hand side equally weighted now? For sure, they're both 5 pounds now. even better, we have isolated for x. So on the left, we've gotten rid of these 1, 2, 3, so we only have x on its own. We've gotten to a point where we know that x, whatever that was, has a mass of 5 pounds or 5 kilos. So how do we apply this subtract 3? So we just did the subtraction principle on the mobile. We subtracted 3 on the left, and we also subtracted 3 on the right-hand side of our mobile. How does this work with the equation? Well, very much in the same way. So let's get started. I'm going to rewrite our formula. So we started with x plus 3 equals 8. I've given myself a little bit of a gap, and I did that for a reason, because now I'm going to be applying the subtraction principle. So we have this subtraction principle. I'm going to be subtracting 3 from the left as well as from the right-hand side. I'm doing it to the left and I'm doing it to the right because I want to maintain equality. When we do this, once we've done it on the left, you'll notice we have a 3 minus a 3. What's $3 minus $3? 0. So we've eliminated this term altogether. So now it has become x plus 0 is equal to, and on the right hand side, we get we get 8 minus 3, which is 5. Continuing, every line I'm going to write, so just so you know, I'm going to write this line by line, and with each line, there'll be something to the left of the equal, something to the right of the equal sign. There will always be an equal sign every line that I keep simplifying. So on the left, x plus 0, I could just say is x. I don't need the plus 0. On the right, we get 5, which is the answer we said earlier. So we said that x has a value of 5. That was our unknown value. Okay, so we just use the subtraction principle. I'm going to go ahead and just highlight that on the left and right. So subtracting 3 here and subtracting 3 here on the left and the right, we've completed the subtraction principle in order for us to isolate and figure out what the value of x is. Let's go ahead and we'll try the addition principle. So in this example, we have the equation x minus 3 equals 5. Again, I'm going to highlight the left-hand side of our equation, x minus 3, and I'm going to compare that to the mobile. So in our mobile, x minus 3 looks like this. The value of x is here, and then the minus 3, minus 1, minus 2, minus 3. On the right, we're saying that this is equal to 5. So on the right-hand side, all of this stuff is equal to 5 pounds, 5 kilos, whatever it may be. So if we want to isolate for x, we want this to be the only thing on the left-hand side of our equation. This means we need to get rid of the minus 3. So to get rid of a minus 3, if you're in debt, negative $3, in order for you to not be in debt, you need to have $3. You need to earn $3 to get plus $3. So on my diagram on my mobile, I am going to give myself plus 1, plus 1, plus 1. So I've given myself 3 plus 1s. So if I have minus 1, minus 2, minus 3, and now I've said plus 1, plus 2, plus 3, each one of these pairs are going to cancel each other out. So if I've added plus 3 to the left, I'm doing that same action on the right-hand side. So on the left-hand side, we have x isolated on its own. On the right-hand side, we have 1, 2, 3, 4, 5, 6, 7, 8, a sum of 8. So x should be equivalent to 8. So let's apply the addition principle by adding 3 to the left and the right-hand side. On the left, we have a minus 3 plus 3. These cancel each other out to give you 0. So now I can rewrite this as x plus 0 is equal to 5 plus 3, which is 8. X plus 0 is just x equals 8. And this is what we've learned with our mobile. So the value of x should be 8. Let's look at the next principle.